Today we are going to discuss the velocity analysis of a slider crank mechanism. So in a slider crank mechanism, the lengths of the crank and the connecting rod are 200 mm and 800 mm respectively. Locate all the instantaneous centers of the mechanism for the position of the crank when it has turned 30 degrees from the inner dead center. Also find the velocity of the slider and the angular velocity of the connecting rod if the crank rotates at 40 radians per second counterclockwise. So hope you have got a basic understanding regarding this velocity analysis by using instantaneous center method. So here we have got 4 links. Okay, so this is your first link, and which is the fixed one. So this is your second link. This is your third link. That means the connecting rod is your third link, and fourth one is the slider. Fourth one is your slider. First of all, we have to find how many instantaneous centers are there for this question. So instantaneous center, number of instantaneous center, n is equal to small n into n minus 1 divided by 2. Okay, so here n is equal to 4. Small n is equal to 4. That means 4 into 3 by 2 is equal to 6. So the number of instantaneous centers will be 6. So next you are going to find the instantaneous centers. So for that, mark 4 points. Next you are going to find out the instantaneous centers. For that, mark points which is equal to the number of links. Okay, so here there is 4 links, so I am marking 4 points and naming it 1, 2, 3, 4 in a cyclic order. Okay, so the fixed and permanent instantaneous centers are 1, 2, 2, 3, 3, 4 and 4, 1. Okay, fixed and permanent instantaneous centers are I12, I23, I34 and I41. So next is neither fixed nor permanent instantaneous centers. So that is actually 1, 3 and 2, 4. So next instantaneous center is 1, 3 and I2, 4. Okay, so these all are the 6 instantaneous centers of our question. So this is the link 1, this is the link 2, this is the link 3 and 4 is the slider. Okay, so here also 1 is there in the cylinder, at the point cylinder it is actually fixed. Okay, so this is the instantaneous center I12. This is I23 and this, that means the gudgeon pin, the pin which is connecting the connecting rod and the piston, that is actually the I34. Now where is this I14? Okay, we know that the slider is moving in a linear manner, right, in a straight line manner, but we can assume that this small straight line is a part of a very big circle. So usually we will be representing the instantaneous center for a slider is at infinity. Okay, so the instantaneous center I14, that means the instantaneous center for a slider will be treated is at infinity. Okay, and usually the instantaneous center will be located in a line perpendicular to the slider moment. Okay, so it will be like this. Okay, so next I am going to mark the instantaneous center 1, 3 and 2, 4. Okay, so first of all 1, 3. So you can see that 1 2 2 3, where is 1 2? 1 2s are here and 1 2 3 is here. So I have to extend this line. Next is 1 4 and 3 4. 1 4 is at infinity. I 1 4 is at infinity. Okay, I 1 4 is at infinity. Next I 3 4. I 3 4, it is located over here. So this will be the intersecting point, and this point will be I 1 3. Okay, so next we have to mark the next instantaneous center. So that is 2 4. Okay, so this is 2 4 and another one is like this. So this is 1 2, right? 1 2 is located over here. This is 1 2 and next 1 4. 1 4. 1 4 is located at infinity. So you can draw a line over here which will be at infinity. And passing through the O. Okay. So next one is 4 3 and 3 2. Where is 4 3? Or 3 4? 3 4 is located over here and 2 3 is located over here. Okay. So you can extend that particular line and will meet a particular point I 2 4. Okay. So these two are the So these two are the instantaneous centers which are neither fixed nor permanent. Okay, next we are going to complete the table. So first we are going to calculate the velocity of the point A. Okay, and I am taking the length of OA and it is scaled to 2 centimeter, and the angular velocity from the question is given as 40 radians per second, and the value of R is equal to in meter 0.2. Therefore the velocity will be equal to 8 meter per second. Okay, 8 meter per second will be the linear velocity of the point A. Okay, now I am transferring this velocity over here. This is 8. Okay, again I am calculating for point A. So here I am going to take the length of instantaneous centers. Okay, so I 2 3 and I 1 3. So the distance between I 2 3, that means this much distance. Okay, this much of distance. Okay, so upon measuring this much of dimension, it will be equal to 9.16 centimeter. 9.16 centimeter, and the corresponding value of R will be equal to 0.916. Okay, so upon calculating, we will be getting the omega value to be 8.733. 8.733. Okay, next we have to calculate the velocity of B. Okay, so for that, just transfer the value to here. That means here 8.733. Okay, so here length will be I13 and I34. I13 and I34. Okay, this much of distance. I have to take this much of distance. I13 and I34, and upon measuring, the dimension will be equal to 5.58 centimeter. Okay, 5.58 centimeter, and the corresponding value of R will be equal to 0.558. 0.558. From this, the velocity of the slider, that means the velocity of slider B. Okay, here B is the slider, so the velocity of slider B will be equal to 4.87 meter per second. Okay, so from the question, it is asked to find the velocity of the slider and the angular velocity of the connecting rod. So this will be the angular velocity of the, so this is actually the link AB, and for that link AB, this will be the angular velocity. Okay. Next, the linear velocity of the slider. Velocity of the slider, that means the velocity of this slider is equal to 4.87. Okay, 87 meter per second. Okay, so I will explain it once again. First of all, you have to identify the instantaneous center, number of instantaneous centers for this particular problem. Next, you have to mark 4 points, which is equal to the number of total links. Okay, so from this figure, you can identify the other instantaneous centers 1, 2, 2, 3, 3, 4, 4, 1 and 1, 3 and 2, 4. These all are the 6 instantaneous centers. Next, you have to locate the instantaneous centers 1, 2, 2, 4, 2, 3, 3, 4 and 4, 1 or 1, 4. 1, 4 will be at infinity due to the sliding motion, which is actually a part of a, which is assumed to be a part of a circle which is having an infinity radius. Okay, so next you have to calculate the, locate the instantaneous center 1, 3. So for that, use this way or this way and this way. So for that, you can use 1, 2 and 2, 3. So where is 1, 2 and 2, 3? Extend that line. Next is 1, 4 and 4, 3. So here is 1, 4 and this is 3, 4. Extend that line. You will be getting the point 1, 3. Instantaneous center 1, 3. The instantaneous center 2, 4 can be located like this. Okay, so this will be 4, 3 and 2, 3. Where is 4, 3? This is actually 4, 3 and 2, 3. Extend that particular line. Okay, extend that particular line. And next one is 1, 4 and 1, 2. So here it is 1, 2 and we know that 1, 4 is at infinity. So just extending that line, it will meet at a point 2, 4. Okay, after that you have to measure this much of distance and this much of distance. Upon measuring this dimension, you will be able to fill this whole table. And first of all, you have to identify the velocity, this value. Then you can find this angular velocity. After that, you can find out this velocity, that means the velocity of slider. Okay, so please try to solve this problem. Thank you.